Good day everyone, I am Anami Dusanan, a reporter of today. My topic is about mathematical logic. So we need first to define about mathematical logic. Mathematical logic, it is a study of formal logic within mathematics. Research in mathematical logic commonly addresses the mathematical properties of formal systems of logic such as their expressive or deductive power. So means it a methods of reasonings, provides rules and techniques to determine whether an argument is valid. So there's a theorem that a statement that can be shown to be true under a certain condition. So we have a example of mathematical logic. If x is an even integer, then x plus 1 is an odd integer. It means that this statement is true under the condition that x is an integer is true. Okay. In mathematical logic, we have a statement or we call a proposition. So statement or a proposition is a declarative sentence that is either true or false, but not both. Mathematical logic is uppercase letters denote propositions. So mathematical logic have examples. In P, 2 is an even number, so it is true. In Q, 7 is an even number, so it is a false. In R, A is a vowel, so it is a true. So we have also an example of not proposition. In P, my cat is beautiful, then Q, my house is big. So we already defined what is a proposition. So we have a propositional variables such as P, Q, R, and S, and so on. We have also a truth values, which are T stand for true, F stand for false. So mathematical logic have a truth value and negation. So truth value is one of the values truth or T, or falsity or F, or false assigned to a statement. So negation, the negation of P is the statement obtained by negating statement P. For example, A is a consonant and negative P, it is a case that A is not a consonant. So we have example of truth table. Next, conjunction. What is conjunction first? Is a statement formed by adding two statements with the connector and, which can be read as and. When two statements P and Q are joined statement, the conjunction will be expressed symbolically as P, V, Q. So let P and Q be statement formed by joining statement P and Q using the word and. The statement P, V is true if both P and Q are true, otherwise P, V is false. So the symbol for conjunction is like this. So if you read this statement is P and Q is true if both P and Q are true, otherwise P and Q is false. So this is the example of table in conjunction. Next, we have a conjunction, so we have also a disjunction. What is disjunction? It is a compound statement formed by joining two statements with the connector or. The disjunction P or Q is symbolized by PQ. Disjunction is false if only if both statements are false, so otherwise it is true. Okay, so let P and Q be statement. The disjunction of P and Q written PV is the statement formed by joining statement P and Q using the word or. So in conjunction, V is a and. So if in disjunction we read as or, the statement P and Q is true if at least one of the statement P and Q is true, otherwise P V Q is false. So the symbol V is read or. So this is the symbol of disjunction. So we have a example of table in disjunction. Okay, next, implication. So implication is a relationship between two propositions in which the second is logical consequence of the first. The most system of formal logic, a broader relationship called a material implication is employed, which is read if A then B, and is denoted by A, B or A then B. So okay, let P and Q be statement. The statement FP and then Q is called an implication or condition. The implication FP then Q is written like this. Like this. Okay, so P is called, if P is called the hypothesis, then Q is called the conclusion. So this is the example of truth table for implication. Okay, so we have example of implication. Let NP, today is Sunday, and NQ, I will wash the car. So this is the example given. P, then Q. So if we read the example given, if today is Sunday, then I will wash the car. So implication has a converse, inverse, and contrapositive. So what is converse? Converse in logic and mathematics, the converse of categorical or implicational statement is the of reversing its two constituent statements. So the converse of P then Q is Q then P. The conditional statement and its converse are not logically equivalent. So okay, in converse of this implication is written like this. Like this. So the example given is this. So if you write in converse, so this is the result. Q then P. If I wash the car, then today is Sunday. Next, in the inverse. What is inverse? When both the hypothesis and conclusion, the F part and P is negated, and the then part or Q is negated. The inverse is referred to as if P then if Q, when stand for not or negating the statement. A conditional statement and its inverse are not logically equivalent. So the similar of the converse and inverse is they are not logically equivalent. So okay, in inverse we write like this. Okay, so if we read FP then if Q, if today is not Sunday, then I will not wash the car. Okay, so in the contrapositive, if this implication is if Q then if P. Okay, so if we read if I do not wash the car, then today is not Sunday. So it is a revising of the inverse. As you can see, the Q and P is different of inverse. Okay, next. By implication. So, by implication, what is a by implication first? Let P and Q be statement. The statement P, if and only if Q, is called the by implication or by conditional of P and Q. The by conditional P if and only if Q is written like this. Like this. If we read P if and only if Q. So we have example of a truth table form by conditional. So mathematical logic has a precedence of logical connectivities are highest, second highest, third highest, fourth highest, and fifth highest. So mathematical logic has English and logic. So in the English, there are many types of sentence. Few of them are functional statements, commands, opinions, questions, and exclamation. But in the objective study of logic, we will use only functional statement or prepositions. So these are the example of logic and English and logic. You cannot ride the roller coaster if you are under 4 feet tall unless you are older than 16 years old. So in Q, you can ride the roller coaster. Then R, you're under 4 feet tall. Then S, you're older than 16. So as you can see in the table, this is we write in a mathematical logic. Next, mathematical logic has a compound proposition. So compound proposition is a tautology, contradiction, then contingency. So what is a tautology if it is always true? Contradiction if it is always false. Contingency if it can be either true or false. Okay. Mathematical logic has also logically implies and logically equivalent. Okay, so what is logically implies is the connective and propositional calculus which has the meaning if is true then is also true. A statement formula A is said to logically imply a statement formula B if the statement formula A then B is tautology. So it is a true. Also it is a true. If logically implies B, then symbolically we write A then B. Then logically equivalent. So what is logically equivalent? A statement formula A is said to be logically equivalent to a statement formula B if the statement formula A then B is tautology. If logically equivalent to B, then symbolically we will write A both B. So this is the example of logically equivalent. If Ryan gets a pay raise, then he will take Allison to dinner. Okay, so it means we can also say that if Ryan does not take Allison to dinner, then he did not get a pay raise. So it is called a logically equivalent. So this is the table of fundamental logical equivalence. So a fundamental logical equivalence has idempotence, associativity, commutativity, distributivity, law of the excluded middle, law of double negation, law of simplification, domination, identity, De Morgan's law, distributivity, law of contradiction, and law of addition. Then we have also logical equivalences and rules of inference per implication are biconditional, and rules of inference related to theorems. That's all. Thank you.